Today we will learn about the IUPAC nomenclature as well as the names of the cyclic alcohols here. This is a cyclohexane. To this, one OH is being added. So I can understand there is only one functional group that is present here. So I should call it as cyclohexane 1-ol. This is the correct IUPAC nomenclature. In order to simplify it, we also remove this 1 and all. We just say it is cyclohexanol. The second one, let's look at this compound here. Here you can see there are two functional groups. Actually, there is one functional group and this is a substituent here. According to priority order, you should prioritize OH rather than CH3. So this gets 1 and this gets 2. So at the second carbon, I am having a methyl here. So 2-methyl, and it is a cyclopentane, 5 carbon system it is, cyclopentanol. We are moving for phenols here. Why do I address them as phenol? I have benzene. To this OH is attached. Now OH is a prior group compared to benzene itself. So here I consider this benzene as a substituent. So I say it is a phenyl. Whenever you consider benzene as a substituent, you address it as phenyl. It is a phenyl alcohol which is abbreviated as phenol. We are looking at the different types of phenols you could have. This is also called as an aromatic.
Ma'am, can you explain that again?
Sorry?
How do you classify something like if it's like not the main thing classified as substitute?
I don't get you. What is it?
Can you explain just the phenol part?
Here benzene is being attached to a very prior group here. So this is my important functionality. So whenever you are having benzene and which is being substituted or having a very good prior group, there benzene is considered as a substituent. Whenever you consider benzene as a substituent, I call it by the name called phenyl. It is phenyl and there is an alcohol here. So this is phenyl alcohol which you call it as phenol.
Okay.
The next one, we are learning about the aromatic alcohols, phenols. We are looking at the different substituents. Okay, if I had a CH3 group that is present along with the phenol, then we will call them as cresols. I have OH, phenol here. To this is my ortho position. This is also ortho position. This is meta position. This is also meta position. This is para position. Now here I can see in this compound to the OH, the methyl group is present in the ortho position. So I call it as orthocresol. This is a common name. We generally do not call it as ortho, meta and para in the IUPAC. For IUPAC it is only numbers. But here I call it as orthocresol. That is its common name. Let us do the IUPAC nomenclature. Which is more prior? OH is prior here. So here this is 1 and this is 2. At the second position I have methyl, 2-methyl phenol. To the OH, this is ortho, this is meta. So I say it is metacresol. Number it 1, 2 and 3, 3-methyl phenol. This is para, so I call it paracresol. 1, 2, 3, 4. So we call it 4-methyl phenol. Clear?
Yes, ma'am.
Right. Now we are going for the dihydroxy derivatives of benzene. 2 OH groups at the 1, 2 position. This is 1, this is 2. So 2 OH groups, if it is present in the 1, 2 position, the common name for this is catechol. And here, as we mentioned in our previous session, whenever there is more than 1 times the same functional group. Here I have 2 times of OH here. In that case, I will name it with the parent molecule only. Who is parent here? Benzene is parent. So it is benzene 1, 2 diol. Clear? If the OH group is present in 1 and 3 position, I call the resorcinol. Since 2 times of OH is present, we call it by the parent benzene 1, 3 diol. Here it is at the I can see they are present in the 1, 4 position here. The common name is benzene 1, 4 diol. If not, we call it as quinol or hydroquinone. These names we have to for sure memorize it. Okay? Shall we continue?
Yes, ma'am.
Right. The next compound, we are moving for ethers here. Ethers are basically the functional isomers of alcohols. What do you mean by functional isomer?
It has a functional group, but in another location than it's supposed to be in.
Just like a chain isomer, if the same functionality is there, with just a mild change, if I am able to produce another functional group, then I call it functional isomer. Let me consider ethanol, CH3, CH2OH. I am just relocating the CH2 to the other side of the OH here. So I have CH3OCH3. Initially it was an alcohol, now it has become an ether. So yes, it is a functional isomer of alcohol. Clear?
Yes, ma'am.
Yeah. We are going for the naming here. How do I name it? The common names of ethers are derived from the names of alkyl and aryl groups written as separate words in alphabetical order and adding the word ether here. So let us look at this. CH3O C2H5. So this is like ROR. One of the R is ethyl while the another R is methyl. Now how do I name it, ma'am? Go for the alphabetical order. E comes in front of M, so I call it as ethyl, methyl, ether. This is common name. We are not talking about the IUPAC. It is common name. How do you name the common name? According to alphabetical order, I just go for my naming here. Now let's go on for the common names as well as IUPAC names of some common ethers that we have. The first ether, 2 CH3 groups are there. So what will be my common name? 2 times of methyl is there. Dimethyl ether. We'll first complete the common name, then we'll go for the IUPAC. Now here, ma'am, both are ethyl. Diethyl ether. Now the next one R is CH3 while the other R is propane unit, isn't it? So we know I'm going to name it only with respect to the alphabetical order. M should come in front of P. So I call it methyl propyl ether. There is no need for you to introduce N and all. It can be called as methyl propyl ether itself. The next one, C6H5 is there. On it, OCH3 is attached. This is methyl. This is phenyl. Which is coming in front according to alphabetical order? Methyl, M. Methyl, phenyl, ether. Now we have a commercial name for this product other than common name. Commercial, na? When you go to an industry, if you are going to purchase this compound, I don't call it as methyl, phenyl, ether. Instead, I have a commercial name. In what name it is being sold in market? It's called as anisole. The compound is called as anisole. We must remember the commercial names, very important. Most of your organic conversion starts from anisole. Go for the conversion. The next one, C6H5O, CH2, CH3. This is phenyl, this is ethyl. Go for the common name. E should come in front of P, ethyl, phenyl, ether. It has a commercial name here, phenatol. Benzene with OCH2, CH3 is called as phenatol. Next one, benzene is there, phenyl, and CH2 6 times. That means 6 times carbon is there and 1 time carbon is there. So totally how much? 7 times. 7 means heptyl. Correct? Go for alphabetical order. H should come in front of P. So it is heptyl, phenyl, ether. Clear? Clear? Next one.
Yes, ma'am.
Yes, ma'am.
I have methyl, and this unit in the last class we learnt it was isopropyl. And this is methyl. Go for the IUPAC here. M and P. Now you may have a doubt, ma'am, I am having iso here. Won't I should come in front of M here? We generally take the importance of iso group and neo group for alphabetical order only for naming alkanes, not functional group identities. Very common alkane is there. In that case, I will give importance to iso IE and neo N. Here I have a functional group, so I don't mind about this isopropyl here. I go for methyl here. M and P. The next one, phenyl. P is there. 1, 2, 3, 4, 5. 5 carbon system, but it is an isomer of 5 carbon. So can we call it as isopentyl? Correct?
Yes, ma'am.
Right? Now here, depending upon ma'am, okay, so P should come, P here is also P, here is also P, then why do you say this phenyl is at first? Because this is more bulkier compared to a normal one, same alphabet, P and P. The next alphabet is H and E. So we expect E should only come in front, so it shouldn't be isopentyl. Phenyl ether, not necessary. Phenyl is bulkier than isopentyl group, so therefore we give phenyl the priority. So phenyl isopentyl ether. Fine. Now for these kind of compounds where I am having 2 ether systems here, or this kind of a system where I am going to have a bulkier nature, a cyclic compound here, there and all I don't have common names at all. I address them only by their IUPAC names. Now let us understand the IUPAC name. How do I name the ethers? CH3O CH3. For IUPAC name, always choose lowest carbon chain to add oxy to this. So if I have ether, for the IUPAC, I generally call it by methoxy, ethoxy like that. For that case, I will always choose the shortest carbon chain or lowest carbon chain. Here it is a symmetrical ether. Both the parts is only one carbon is there. So I don't mind where I am going to add the oxy here. So I say methoxy because CH3 is there with O, methoxy, and one carbon is there, methane. There is nothing wrong if I am going to do it from the other side. O is there, one carbon system is attached, methoxy, and one carbon is attached in the left hand side, methane. Okay.
Yes, ma'am.
So for the next one, again same logic here. Both are C2H5. So I called as ethoxy ethane. The next one, CH3, O, CH2, CH2, CH3. This side I have only one carbon, but this side I am having three carbons. So OXY should be added to the lowest carbon containing chain. So this is my lowest carbon containing chain. How many carbon? One carbon. So how should I call it as? Methoxy. And how many carbons are there? Three carbon. Propane. Methoxy propane. Let's go for the next one. Benzene is there. OCH3 is there. What did I tell you? Take the shortest chain to add oxy. There is one carbon here. There are 6 carbons here. So one carbon is smaller. So I call as methoxy benzene, which is also called as anisole. We already saw that. Same again. I have benzene. I am having O, C and C. 2 carbon here. But here it is 6 carbon. So I take this is my shortest chain. I call as ethoxy benzene. Clear?
Yes, ma'am.
Yeah. Ma'am, why is this they are continuously addressing as 1 year, 1 year? It means to say this carbon is a primary one. That means this is my chain from, for example, let me say like this. CH3 is there, O, C is there. From this only my functional group started, na? So I number from this 1, 2, 3. 1 methoxy propane. From this only my functional group started. Correct? From this only my functional group started. So in that case, I number it as 1.
Yes, ma'am.
Same logic here. 7 carbons are there. From this only my functional group started. So I say 1 phenoxyheptane. Look at this case here. 1, 2, 3. Correct? Choose the longest chain. That's the most important rule of your locant principle. Choose the longest chain. I'm choosing my longest chain. It is 2 here. At the second position, there is methoxy. 2 methoxy propane. Correct, Ra? Look at this now. 1, 2, 3, 4. At the first position, I'm having this.
Ma'am, can you explain 2-methoxypropane again?
This is a position where it is present. I can't number from here. That's not possible because it is a branched one, or which is an isomeric part. Secondary carbon only, the functional group is attached. In previous cases, it was not the secondary position in which it was attached. Can you see this? The carbon is attached with only one carbon. So I just addressed it here. But here it is not the case. The carbon is a secondary carbon here. It's attached with 2 carbons here. So I have to go for my longest chain like this only. Understood?
Okay, ma'am.
Next one. 6 carbons here. And how many carbons here? 5 carbons here, right? So in that case, what will you do? you will give the numbering to the less number of carbon to add oxy, right? So this carbon is only having less number, so oxy should be added here. Shouldn't we say that? So 1, 2, 3, 4, 3 methyl butoxy benzene. Are you understanding?
Yes, ma'am.
The next one. Now you can see the functional group has increased more than one time. So I should choose my parent and I should say where is the functional group. This is 1, this is 2. At 1, 2 position there is dimethoxyethane.
Ma'am, why ethane again?
Because there are 2 carbons here. That is the parent chain. Clear?
Okay, ma'am.
Yeah. Next one. The cyclohexane is having 2 substitute. There is methyl substituent and I am having a functional group here. Right? You should have learned in your 11th standard regarding the functional group priority, ethers are generally not considered as prior group at all. You don't give a priority at all. You always look for the locant sum here. So in this case, if I am going to number this as 1 and this as 2, let us check the locant sum. 1 plus at the second carbon there are 2 substituents, so I should say 2 plus 2, so totally it's 5. Now I am checking the other way around. If I am going to provide 1 to this and 2 to this, at the first carbon there are 2 substituents, 1 plus 1, and second carbon there is 1 substituent, 2. It is 4. You can see it is having the lowest sum here. So therefore I prefer to do this, isn't it? So as I prefer to do that, I am looking for the nomenclature here. At the second position I have ethoxy going for the alphabetical form. At the 1, 1 I am having dimethyl cyclohexane.